Now, before we start, I would like to ask a few questions. So first is like, how many of you are like new to Flutter? Like, if you can raise your hands, that would be great. Like, absolutely beginner. Okay, perfect. And how many of you are like new to shaders? Like, you're hearing it for the first time here. Okay, good. So a little bit about me. Hi, I'm Rutvik. I'm a Flutter dev at Pieces. So at Pieces, we are building an AI assistant that basically helps you remember your workflows and can resurface whatever you are done, whenever you are done it, to you in an accessible manner. And I'm also a maker of app shots. It's one of my indie projects. It's like a design tool for creating App Store Play Store screenshots. Besides that, some of my fun creative projects also sometimes turn into like packages, like this audio waveform package. And in my free time, I like to build fun things, exciting things using Flutter, shaders, music, animations, and other of my interests. So today, we are going to talk about shaders, one of my favorite topics, and what is shaders in general, and how you can use it in Flutter. So first of all, like Flutter's promise from the start on has been that to give you absolute control over the UI, right? To help you build and create beautiful UIs with less efforts. So it has been so far doing its job really well, and we'll see where shaders come into play to kind of elevate those UI UX experiences for your apps as well as games. All right. Now, a general idea of shaders. So there are different types of shaders, like shaders that work in 2D graphics as well as those in 3D. But the one we are going to talk about, the fragment shaders, these are 2D shaders which work with pixels on the screen of your devices, right? And we deal with the pixel positions and their colors. So these are basically shaders are a program that are ran for every pixel on your machine screen on the GPU in parallel. And you get a pixel level control here, which is really crucial if you are trying to build experiences that go beyond the traditional UI UX that you see in apps, like where you want to create visual effects like you see in games. So that's where that pixel level control is going to help, and we'll see how that translates to Flutter. So with this absolute control over what is being rendered on the screen and how it is being rendered on the screen, there is an inherent complexity to it. Like we are dealing at a much lower level on the machines. So they are a bit difficult to understand and learn, but they give you that control over what you're rendering. And the shaders are basically like a math here. So it just, everything is math at the machine level, hardware level. So there's a lot of math involved here, but don't be scared. It's a gradual journey, but I think you will find it really interesting. And you might learn to like love math as well, like after learning about shaders. So first thing about shaders is that they run on GPU. Now, why GPU though? So when it comes to CPU, we know that it's a sequential machine, right? It runs tasks one after another. Like you have a drawing, you might paint the subject first, then the background, and then other parts of the painting. But with GPU, GPU is built for parallel processing, where you can execute thousands of operations in parallel at once. So that's where the shaders come in, like they run on GPU. So you run these operations for every pixel on your screen at a time. Now, shaders is not new to Flutter, to be honest. Like it is inherent part of its rendering pipeline. So traditional rendering pipeline of Flutter is that you have your widgets, which are like the configuration layer, where you tell Flutter, OK, this is a container, and I want it to be this much height, this much width, this color. So you kind of give those design details to Flutter. And then that information goes to render objects. They take that information and use that while they are laying out the specific widget. Like, so render objects control the layout of your widgets. Now, past that layer, once that information is gathered, that information is translated into Canvas API. Now, if some of you who have worked with custom painters with Flutter, so that is the layer below render objects in the rendering pipeline. So that it's like a canvas that Flutter provides you. So all those instructions from render objects are then converted into a painting-like instruction, like this: draw circle, draw rectangle, draw shadows. A minimal set of instructions. Well, now, once we have those canvas instructions, then what Flutter does is that it takes those painting instructions, then creates a shader program out of it, that can be then sent to the GPU for the final output to be rasterized and shown on the screen. So in the final pipeline, everything comes down to a shader, and the GPU gives you the output of that shader that you then see on your mobile apps or your machine. So that's the basic pipeline. So what we'll do now is try a general hello world in raw shader code without first jumping to Flutter. So that will give you an idea of like what shader code might look like and how you can work with it. So a few high-level abstract things before jumping into the shader program. Now you might wonder like what languages are we going to use for writing fragment shaders. So when it comes to fragment shaders, we work with OpenGLSL. It's an OpenGL shading language. It's one of the widely adopted ones that is quietly supported across all platforms and all of the hardware graphic drivers as well. So it's like it has a C-like syntax and some of the similarities of Dart, but we'll take a look at that in a bit. And fragment shaders, as I've told, these are 2D shaders working with pixels on the screen. So we are dealing with a vector math here. We'll deal with the position of the pixels, and finally, the output will be the color of that pixel the program is going to tell us. Now, when it comes to the colors of the pixel, we are also going to be dealing with color channels, like RGB, a standard format for color, right? So it represents like red, green, blue, and the fourth is the alpha channels. So we'll be playing along with the color channels as well to get the color of pixels. And one of the things that a simple rule to follow when you're working with shaders is the normalization. It's just a basic concept where you take a particular range, like it may be 0 to 1,000, 500 to 750, or any range like that, and convert that range map that range to a 0 to 1 range, basically. So why 0 to 1? Because it's just so much easier to handle and work with, like when you're working with different values. So it makes it easier to kind of calculate things in your head as well. So normalization is something that you would find yourself doing when you're working with shaders. OK, so what we'll do now is I'll show you a quick little example of a shader code. Right now, so we are working in an web IDE. It's called editors.bookofshaders.com. It's an online site where you can like write a shader and see its output in this box over here. You can drag it here. Now, if we go over the code, what you'll see is that, first of all, we have some definitions here. Now, this is the pre-processing code. Now, GLSL supports pre-processing some of the code before the actual shader is compiled. So this is where you might define some platform-agnostic values, like what should be the precision of the floating points that you're dealing with. And then there are some global values that are present within the shader program, like the resolution of the screen that you're going to outputting your shader to. And the time, this is the U time, that is basically passed since the shader has started. So this is something that you can use to animate the shader. Now, if you will recognize the main function, like Dart has the main function, like a high-level entry program, high-level entry path for the program. Similarly, we have a main function here. And the first line is, it defines a variable called st. Now, what st is the normalized position of that pixel on the screen. How did we got that normalized position? Is that this GL frag coordinate. It's a global value available within your shader program that gives you the absolute position on the screen, like whether the pixel is at 100 by 100 XY coordinate or anything else. And the RU resolution.xy is the total size of the screen. So we just normalize that value to a 0 to 1 range, so it's easier to deal with. And now, as I said, we'll be doing some vector math, right? So a color is like can be defined as a 4 vector, right? You have 4 different channels. So right here, I have defined it with a vec3, which is basically x, y, z. But as it's a 2D, we don't really care about the z coordinate. It's mainly used to treat it as the RGB channels. So here you can define the colors. Like this will be within a 0 to 1 range. Like for an 8-bit color, which is like 0 to 256 color values you have. So that is basically normalized to a 0 to 1 range. So you can then map your position and the colors simultaneously as you want. So you can change your colors, like define them here. All right, and you can see the output on the screen. So the program's final thing it has to do, it has to set this GL frag color. That is the final color this pixel is going to have. So right now, for all the pixels on the screen, we are giving it the same color. So you can see a bright yellow box over here. Now, what you can do is you can change this color to be dependent on the position of the pixel, right? Now, when you add that position in the equation, some interesting things happen, actually. Like, you get this different gradients going on. You don't have to deal with static color itself, but now you can play around, create different variations of what you're rendering on the screen. And so that's how you can map the position to the color channel, and that's where the normalization is important for this mapping on the screen. Now, beside that, you can also animate things in shaders. Like we have this uTime variable. That is basically the time that has passed since the shader has started. And what you can do is use that variable in a way that suits you to kind of animate the final output. Now, this is where the transitions that you see in video players and everything, that's how they are done, basically. And finally, whatever color you have set, you can assign it to the GL frag color, and that will be the final color of that pixel. So in short, this program is running for all the pixels on the screen in parallel on GPU, and you decide on the color of the pixel based on its position, like however you want. So that's the basic GLSL code that we have here. Now, what we'll do is jump to Flutter side and see how shaders can be included within Flutter. So for this, we are going to rely on a Flutter shaders package. So it has two important things that we care about, to be honest. It's these two APIs, a shader builder and an animated sampler. Their purpose is simple. The first one basically gives you text in the shader file, whatever code that you have written here, that shader file, and creates an shader instance out of it. And then you can use that shader instance to send any inputs to it or gets it output. And then this animated sampler, this is something, it's dependent, if you want to use it. It basically gives you the child texture of a widget, and you can send that image to shader as input to kind of manipulate the image, in video filters or image filters. So we'll take a look at those two things in a bit. A simple example of shaders is that now one of the biggest things that shaders help is create repetitive patterns, right? Because it's yeah, so right here you can see it's a striped pattern, nothing interesting right now. It just strips. You can basically do this with custom painter or widgets. Nothing interesting about it. You can rotate it. Same, you can do it widgets as well. Increase the number of stripes that you see. Animate it as well. But something that the widgets or custom painters or any other rendering APIs within Flutter can't do is create effects like this warp effect, right? Where you're not just creating this light, but you're adding this warp effect that kind of distorts the pixels on the screens in a way you want, which is pretty crazy. I mean, you don't get this level of control just through custom painters. So this is where the shaders shine really most, to distort pixels in any way you want. And you can also, these are basically inputs that I'm sending to the shader to kind of manage the output of it. And you can also change, send color as an input in a vector format. And you can create some cool effects like this. So repetitive patterns or textures, you're working with leather textures or particular textures. So those are some things where shaders can help you create those things. Now, before taking a look at the code, this is one example I want to talk about, a shader mask, another way of using shaders in Flutter. Now, you have your shader builder, which is going to take the shader file and create a shader instance out of it. And what you can do now is use this shader mask widget in Flutter. What this shader mask widget is going to do is going to take that shader, it's take the output of that shader, whatever it is outputting, and map it onto the child that you provide to it. The child can be any your Flutter widget, like a text, image, or whatever you want. So you can map that shader output on the child, and you can decide on the blend mode for it. How do you want the two textures to kind of get composed, right? So in that way, you can create some interesting things like different mappings for images, text, etc. So this is one example. And Now, so far what we dealt with a bit static example. Now, dynamic VFX, what do I mean by dynamic? Is like manipulating what you're seeing on the screen, like maybe a text field or user interactions or your app is looking, right? So that's where the animated sampler API comes in handy. Like, so the shader builder is going to give us the shader instance, and this animated sampler is going to give us the texture of its child. Like basically, it's going to capture the child as an image, and then you can use that image, send it to a shader to kind of manipulate it. So here you can see, like I got a normal text field, but if I try to type into it, you can see that it has got that kind of glitch effect, right, on top of it. Now you might like to apply this glitch effect in your apps or somewhere in games. So things like the dynamic visual effects of distortion of the pixels of your UI can be something that's where the shaders are helpful. So if we look at the code that animated sampler is going through, so first of all, we got our shader instance here, and then the image, that is basically the capture texture of the child widget. We take that image as an input, set some floating values like inputs for the shader, like the size of the screen on which you are outputting the shader, and the precision, I believe this is the, okay, this is the delta. Yeah, so that's the time that has passed. And then you can send images, image objects as well as inputs in the shader, as I explained, through the set image sampler API. And basically, we give that shader for the canvas to, we are telling canvas to basically show whatever the shader is outputting here. Okay, so that's how like you can work with dynamic UIs and shaders in Flutter through this animated sampler API. Now, one of the sorry. So one of the things that this unlocks is that new theming opportunities. Like, you know, you might not want your app to look a certain way, or you might want your app to look like it's built in the 90s, right? Black and white, maybe get some distortion effects going on or something like that. So you can basically do that with shaders. Like, it is still interactive, but the whole theme has been changed due to the shader. Like we are sending the whole output, whatever the Flutter is outputting for the child as an input to the shader, and then manipulating that image every frame. So Flutter is capable of doing this every frame. It has good performance so far. So you can like explore different themes for your apps. You don't have to be limited to Material or iOS only with shaders. It unlocks a variety of opportunities for you. Now, one of the other examples is the shaders can make a boring UI feel more joyful, you know, more interactive, like something that people might want to really use on day-to-day basis or have fun using. Right now, here is an example of like a page view widget, which basically allows you to add different pages that you can slide through. Ordinary, you see this in everyday apps. But to make it something interesting, you know, to let users have more fun with the UI, what you can do is this example uses shaders to basically create this page flip effect, like you see in books, right? You have this nice little page view effect. So like Kindle or Amazon, the books, the apps, they have this effect going on when you're reading, right? So it makes it kind of gets you more involved in the process, makes it more fun. So this is something that shaders can help you. Now, behind the scenes, what's happening here? I won't be taking a look at the code, because right now we don't have the time for it. But on top, like what's happening here, it's simple page view that is being rendered. And I'm capturing both the pages as images, and using those two images as input to the shader. And then finally, shader kind of does a lot of weird math there. But it's like a black magic. But it does a few mathematical calculations there to create this page view effect that you can see going on here. Now, one other thing that I think I missed was showing that although shaders are very powerful, you might think that it takes a lot of code to kind of create this graphic, right? It might be 100, 200 of line. But the crazy thing is shaders code can be really like very concise. Like, so this is the code for this stripes example where you got the warping going on. You can animate the things, change colors, rotate it. If you had to do it in Flutter, yeah, it will be hundreds of lines of code and not even fully possible. But with shaders, the only parts of actual code that are doing the job, it's just this barely like 20, 25 lines. So at this lower level where we have this absolute control over the UI, codes are like very short, they can be concise, depending on the complexity of it. But yeah, that is it. All right, jumping ahead. Another example here is just something fun little project that I built with a shader. Now in games or like in anime, you might see this strips to represent kind of speed sometimes, right? A kind of visual effects. Now if I like hold on here, you will see that this we get this nice little visual effect that emphasizes speed, like you're going really, really fast, and it kind of increases with time, and if I release it, it kind of slows down. So you can control the shader animations as well through Flutter, which is nice, yeah. So you can create lots of this cool, crazy effects for your, especially games. I mean, games are what, like visual effects on top of visual effects, right? So shaders are used in abundance over there. So this is something games really rely heavily on shaders, like 2D as well as 3D shaders. Another example was, so this was a little shade snap. This was one of my small projects that I built a couple years ago. Now, few things that I wanted to do with this project was, just build something fun. I'm learning this new technology. I want to build something fun, exciting, and I wanted to see how far I can push Flutter's UI capabilities. And third is basically replicate any real-life features from like Instagram or Snapchat, the image video filter. So I wanted to see if I can create that within Flutter using shaders, like was it even possible? So I'll show you the app right now. I think it's a really good examples of using shaders and Flutter to create some exciting apps that might be otherwise not possible. Just give me a second till I share my phone screen here. Okay, 3, 2, 1. Yeah, here we go. So this is the app that I'm talking about. So you can see that I have this different filters over here. It's taking the input from the camera, and it's passing through the shader, as I said, like sending it as an input to the shader, and running it for every frame. So that's how you can, like, the filters that you see on Instagram or Snapchat, like blur filters or like sketch filters, or that just adjust the colors of what's being rendered, right? So there's something shaders are really helpful. Like you can literally manipulate the image or the video that you're showing. So this was a fun little project that I built. It was a lot. I mean, it was in terms of complexity. You're dealing with shaders. I think shaders was the only part that was really complex, because this different shaders, like different visual effects. Like you need to have different methods and formats for dealing with them. But it turned out to be a really fun project as well. Like something interesting, something that showcases how shaders are being used in real life, where a normal person can relate to, right? So this is one cool example of it. Now let me just, okay. All right, so that was Shade Snap, one of my really fun projects. Now, the question is like, when should you use shaders? Now, there are times when you definitely need a shader, like, but it also depends. Like sometimes you might be able to replicate the effect that you're trying to achieve with just widgets or custom painters. It might be more computationally heavy and a bit messy, but okay. But some experiences like manipulating the literal pixels of the images, videos, or create some of the examples that you have seen before. So that's where the shaders shine the most, and there you will have to use shaders for your apps and games. Similarly, when custom painters render objects don't cut it, shaders can be your savior. And as I said, textures and repetitive patterns is like the holy grail of shaders. So that's where they shine the most. And when you want granular control over rendering, as seen in the example, right? So you can use shaders there as well. Some of the challenges with shaders is that they are inherently complex. Like the layer below shaders is literally assembly, like zeros and ones. It's just an API on top of that assembly language that helps you dictate the graphics that are being shown. So there is a lot of math there, but I feel like, and the learning curve is also a lot, but it's not the impossible journey, I would say. Like if you could get into it step by step gradually, you will try to understand the basic, like there are not a lot of math that you need to know to learn shaders. It's just repetitive things that are used in a different ways. So once you get into shaders, you will understand, okay, these are some set of things that are absolutely needed, and others can be optional. Like one can do a certain thing in shader using one formula, one might use a different formula, you know? Sometimes it's more about just getting things done rather than how efficient the algorithm is. So, but yeah, it has a bit of longer learning curve than other rendering techniques and can be computationally heavy as you're running this algorithm for every pixel on the screen, every frame. So more computations means more battery consumption. So be aware of the user's battery. You don't want to like drain it like in an instance. So you like most times you won't have to care about it, but if the shader is really complex, then you'll have to check this out. Yeah. So where you can go to learn about shaders. Now, Daniel Schiffman, the coding trend, one of my absolutely favorite YouTube channels. So he shares his creative journey, and he has worked with shaders as well. I would definitely recommend to follow him. Like he doesn't code in Flutter, but some of the learning from the other frameworks that he works with shaders can be translated to Flutter. It's fun, yeah. And then book of shaders, like if you're absolutely new to shaders, or you know, even if someone with a bit of experience, I would recommend to go through this book of shaders. It's a nice, it gives you a really good idea of like what shaders are, goes in depth into like from writing your first line of shader code to kind of working with different textures, patterns, and do a lot of crazy things with shaders. And then I also maintain, like most of my fun projects end up at this location on GitHub. So they have some of the shared examples as well. So you can check that out. And so for me, usually when I'm building something fun or exciting, I take my inspiration from video games, movies, and music particularly. So for you, if you like something, like you might like music, so try to involve music in the project that you're building. It just makes the process more fun, enjoyable, doesn't get boring. And so there are beside folks from the Flutter community that you can follow, like Rena and Roa, Super Declarative, Ro, and G Skinner team. Like so, these guys do share some shader content on Twitter sometimes. I would recommend you to give them a follow if you want to dive deeper into these things. Yeah, Atlas. So thanks a lot. I hope you enjoyed the talk. And if you want to connect with me, you can. I'm mostly active on Twitter. So I'll be sharing the slides on Twitter later today. But yeah, you can connect with me there. And if you have any feedback on the talk, you can like scan this QR code and just share that feedback. So yeah, thanks a lot.